Well, it said it, so I hope it does. But yeah, let's go on to number 28. Again, if anyone needs like a question done, then I'll do that. Anyone got any particular things from chapter 28 that you want to focus on? Like nonlinear systems, like other like phase portraits and stuff like that? I'm just gonna drink my tea. Well, it comes to spilled some water everywhere. You can go over nonlinear systems. Yeah, okay. So we'll be doing 28.4. What's that? It just sounds. Conditions for oscillations and alternations. Okay. The oscillations and alternations is easier to explain, so I'll go over that first, and then I'll go over nonlinear systems. Okay. So I think I updated this because I slightly got it wrong earlier. So pardon me, but I've changed this. So the conditions for an oscillation alternation and explosive versus dampened behavior, which I love that sound, explode you one person. Yeah, where is it? Here it is. I wrote it down here. So if we are given eigenvalues, we want to see if they're explosive or dampened. So that is done for the modulus. Okay, if you've got a real number with over a modulus, for a real number it should be easy. Like if it's 0.8 versus 2, this is dampened, this is explosive and explosive. That should be fairly obvious because that's like a quite clear modulus. For a complex number, if we had 1 plus I, that has a modulus of root 2 and is therefore explosive. Okay? Whereas if we had something like, I don't know, 0.5I plus I think that's less. Let me think. Yeah, that's only like a modulus of, what is that, 5 over 4? Half squared, 1 plus, it would be root 5 over 4, which I believe is under 1. No, wait, it isn't. Yeah, so that would also be explosive. Yeah. So, yeah. So you've got to think about like what the modulus of the complex number is. That will determine if it's dampened or explosive. In opposition to alternations and oscillations, okay, it's only oscillations if there's an imaginary part. Hello.
How you doing, mate?
I'm good. I've got to get on with this. So just one
I
moment.
know.
So there's an oscillation if there is an imaginary part. This can be found on page 629, if any of you are curious. Not in that way. But yeah, 629 at the bottom. Xt displays oscillations around the particular solution if and only if some eigenvalues have a non-zero imaginary part. So, for example, this would display oscillations, this would display alternations. Okay? So complex is oscillations and real is alternations. Is that clear? I'm just going to look down at the chat just every now and then. Jeff, I am prioritizing all your questions today. You're lucky as hell. Right, let's see. Yeah, yeah. I'm just going to see if it's all good. Yeah, okay, cool, all good. So let's go over nonlinear systems. Now, for a nonlinear system, the eigenvalues pretty much tell you the nature of the system, so it should be fairly obvious. If we have, let me just get to 18.4. There's a fishery example here. No, that's chapter 30. What the hell? Where is it? Just trying to look over everything. It's a big book. But yeah, we have autonomous systems, global stability. Hold on, let me just get to everything. So, nonlinear systems, you are given, yeah. Where is everything? Oh yeah, okay, cool. So this is the phase diagram. Oh wait. Sorry, this is a little, you can't see what I'm trying to kind of flicking through my, yeah. Oh god, I think people are leaving. Oh, Question 28.2.3. Yeah, I can do that later. Okay, so we'll just go over nonlinear systems now. So we assume we have a system which essentially has basically two dynamics to it. So we've got dx dt, which is some function fxy, and we have dy dt, which is some function gxy. All right. And we've got that. So stationary solution is the first thing here. So a stationary solution essentially allows that fxy, gxy for some specific value of x and y. Just that's an asterisk, by the way, equals 0. So normally it is x equals 0, y equals 0 if you've got like an x and y thing, which is why most nonlinear systems have a stable point at the center. But yeah, that's pretty much it. So let's try, for example, let's say we have, let's say, so if we wanted to create a phase diagram, let's use, hold on, do I have an example in here? Yeah, I think there's an example in the 2017 examination that I think Denton brought up, if he's in the meeting. He is not. That's a shame. I can't give him credit. Denton came up with this one, by the way, so thanks to him. Where is it? It is down at the bottom, I believe, this. Yeah, so this is a system, a nonlinear system here, where you've got the following. Confirm. We've got dx dt equals 3y, and we've got dy dt equals 4x minus y. Okay, so generally we would find the stable branch in this case, so we can do that. But what's easier to start with is generally finding, oh dear God, I've zoomed in massively. Generally what's easier to do is just start with the phase diagram straight off. You can write kind of like stable lines? It's the lines where the derivatives equal 0, so it's much easier to sort of look at. So you have this here. So when this equals 0, 3y equals 0, so y is equal to 0. So hold on, let me just do a two-dimensional one here. Yeah, so y equals 0. This is one of the sort of, x dot equals 0. So that should be fairly easy. When y dot equals 0, y equals 2x. So that is one of the lines. Y dot equals 0. Okay. Now let's just go with let's just do actually, I'll tell you what, I'm going to enlarge this slightly just to make it a little easier for everyone to see. Okay, let me just move this over here as well. There we go. That's a bit easier for me. All right. Wait, can everyone see this? Yeah, they can. Okay, cool. All right. So we also want to get the stable. So we can do the following matrix equation, which is x dot y dot, which we're representing the derivatives. And we're going to do the matrix here. This one, I believe, is 0, 3, 2, negative 1 times by xy. If you guys can see that, you can get the equations in the same way by just timesing the matrix on the right side. We get the eigenvalues and eigenvectors from this one. So I believe that is, so you have, I think you get that is the characteristic polynomial, if anyone wants to. No, wait, that's not right. Sorry. Oh, God, there's a lot of people here. Okay, so we've got, so it's going to be, hold on, let me just do this by hand just for a second. Minus 6, that, minus 6, is that right? Oh no, it's plus, yeah. And then, nope, it is plus, yeah. Everything seems good there. So we've got that as our characteristic polynomial, which gives us, I believe, minus 2 plus 3. Yeah, so we have 2 and negative 3 as our eigenvalues. Okay, we can then insert these to find the eigenvectors, I believe. So I believe for 2, it's, I'm just trying to think about this here. 2, you get negative 2, 3, 2, negative 3, which is just like 2x, negative 2x plus 3y, 2x minus 3y. So so the eigenvector there is just 3, 2, if that sort of makes sense. For this one, you get you get positive 3. So you've got 3, 3, 2, 2, which I believe. So the eigenvector is just 1, negative 1, I believe, because you've got 3x plus 3y equals 0, and then 2x plus 2y equals 0. Does that make sense? Just tell me if I'm not making sense for a second, because I just need to know. So we have that there. So we can then sort of make a general solution for that, usually, which I think is just going to be y. I'm just doing the general thing for what is it? Yeah. So the derivative general solution here, which you get, I believe it's e to the 2t 3 2 3. Why did I put that sign there? Hold on. And then you've got ce to the minus 3 2. To be honest, just heads up, I haven't done too much of this. I'm actually going to be revising this a little later tonight, so this is still a little tricky topic for me. Just heads up, because this might not be perfect. But anyway, this is fine enough to find the stable line. But you've got the stable line here. You can find the stable branch by looking for negative eigenvalues. So the -3 negative eigenvalue shows that that branch is stable. The 2 isn't, okay? So if we wanted to know where sort of all the points go, you would look at this one, because this is the unstable one, so everything's just going to be shooting off in that way. This one gives us a gradient of, I think, y equals 2 over 3x. So on this system, everything would just be shooting off these two ways, really. And the stable line is, sorry if I'm being boring for some people, because some people are leaving. So for the stable line, this is a negative x, I believe. Yeah, because it's going to be x and then y goes 1 down. So the stable line goes along here. So everything moves inwards along this line. So we understand that also the stable point is 0, 0 in this case, because, setting each to equal to 0, each basically, yeah. So setting each function equal to 0, you would get x equals 0, y equals 0. So this is so you've got those invariant lines with the derivatives. You've got the line where it all kind of shoots off, and the line where the stable branch where it all keeps centered. So the actual phase portrait may look something a bit more like this, where you've got a sort of situation. If that makes sense? Does that make sense? Yeah. So that's sort of like how you would maybe do it for this case. That's how the phase diagram would sort of look. I know it's a bit messy, so sorry about that. But yeah, I am aware that there's also a solution for general solutions for x and y. Can't do that yet. You may have to come back to me with that. But that's what I understand about phase portraits so far. Does anyone else have any other info for this that they may want to educate the group on it? Because it's not just me giving a lecture, it's like multiple people. Anyone? Oh. All right, Jeff, whatever you want. So yeah, I can go on to question 28.2.3 if you'd like now. Is that okay with everyone? Or does anyone want me to keep on with this? I'm just going to assume I'm going to move on. All right, moving on. We are going to go for, question now. So we're looking at 28.2.3, which, if I remember correctly, is like some kind of equation question here. Oh, damn it. Yeah, simple swarm, system of differential equations. Yeah. I think Oh, yes. Okay, yeah, I think I got this. Yeah, so this is a similar thing to what we just did, I think. I think I barely got this. Yeah. So we're setting up our system of setting us our matrix system here. We get, because we've got x plus ay, we've got 1a, I believe. People are leaving. Sorry if anyone's if I'm a little boring for someone. But yeah, should be our matrix here. So we've got x and y there. All right. I believe, getting the eigenvalues of this matrix, you get 1 minus, yeah, so 1 minus that. So you've got these. And then you've got plus a there. So then you've eventually up getting, yeah, -2 plus that, plus a. I believe the result of this was, yeah, so you have to solve this one. So you've got a plus 1. I believe the result of this was like a 1 plus or minus I. I'm just going to use online calculator for this. By the way, I just use Wolfram Alpha a lot because it just works quite easily. So I'm just going to do this, if you guys don't mind. Just kind of easy, you know? I know it's technically cheating, but it's an open book exam, so screw it. Oh yeah. How much? What's the thing? Oh, the roots aren't that. Oh, right. Okay, well, I'm kind of an idiot. Okay, was it not complex roots? Okay, one moment. Yeah, okay. So I get roots of this, negative a. Oh, we just do plus or minus then. Is that one? Is that correct? No, it's not. Oh, it is. Yeah, it is. Okay, so for that, I'm just going to look through this. Oh my god. One moment. Is the roots that way? I swear I had complex roots before. Yeah, I thought I did have complex roots. I thought I had like roots of +1 and because it's a negative. Did I do something wrong here? If, Rochelle, if someone told me that I've done something wrong, can you tell me what's gone on? If you can determine it. All right. So I've got that there. I swear I had a complex root for this before. Did I not? So it just says yeah to me on WhatsApp. But yeah, let me check here. Yeah, so you've got the general solution there. Yeah, okay, hold on. Let me just. I must have done something wrong here. Sorry about this, everyone. Not sure. Complex because the square root of negative a is complex like it's AI. Oh, yeah. Thanks for that. No, that is correct. Yeah. So we can separate this. Yes. Oh, I'm such an idiot. Yeah. Thank you. So yeah. So we can separate this into -1 and -a, which gives us 1 plus or minus root AI. There we go. Sorry, I'm such an idiot. Okay, right. So then we can use this for the general solution, which I believe is just. Where is this? Oh god. Okay, yeah. So can't you put this into like? That's where you could put this. No problem. Okay. Out. Do something wrong here. Okay. So to find. Dear Lord. Right. So we've got that kind of stuff. Also, if anyone needs another question after this, feel free to tell me. But yeah, we need to insert these, don't we? Do we put these like power of A? Or power of E? Power of A? Jesus. Okay. Yeah. Sorry, I'm getting a little flustered here. But yeah, the general solution is yeah, okay. Oh wait. Where is the general solution? This is a yeah, so we know that this is a system of. So these are not complex roots with negative. This is complex root with a positive root part. So we know that this is a spiral source diagram. So we'd have something that looks like sort of like this, going outwards. That's sort of how it happens. Just trying to find the general solution for this. Yeah, okay. It's telling me here. God, I'm an idiot. Oh, I feel such like an idiot right now. Yeah. Is it the real part ends up there? No, it is the No, wait, hold on. Is it like x is equal to some like constant c, and then you get like e to the power of 1 plus root a I t, like something like that? Or is it not that? No, it might be that. Is it that? I'm trying to like recall it. Sorry about that, guys. But yeah, I think it is that. Is it? I'm very well aware that I may be confusing more people here. Yeah. So yeah, okay, yeah. If it is, okay, I'm going with Rochelle here because she's told me it is, and then I'm going to go with that. So separating, you get x equals to et because we're separating out the power here, timesing by root ait, I believe. And then we've got y is equal to the same kind of thing because we can separate it out. And this is negative root a it. And this is, we can put it into trig form, I believe. So we have, then we, after we put it into trig form, we can do like e to that, which I believe is just, what was the solution for this? It was like cos and sine, wasn't it? It was. There's a problem there because if it's only one, then I don't know how to put it into trig otherwise. What was this? Yeah, hold on. I'm just going to get the answers up online. I think I searched. Yeah, there it is. One moment. There it is. Just grab the answers quickly. I think it was cos and sine, wasn't it, the last time I looked at it? But it is definitely e to the power of something. I've gone far too far. Yeah. If anyone has an easier question after this one is really hard. Yeah, so it is cos AT as the result of that. The problem is I'm not seeing how that results in cos AIT. Have I done something wrong halfway? I may have. I'm glad that this is probably not going to show up in the MCQ tomorrow, but it could. It could do. But yeah, I would see that with this, like in that case, I would assume that if yes, because that in trig form, you would have root A in there, like AT, root AT, but that would give you cos root AT plus I sine root AT, which isn't correct because that's not what the question is saying. That's what I'm getting is the weird thing because I know what the answer is, but what the solution steps I'm taking aren't leading me there. It's weird. The other one is fine though because like, try to get back to you after this. Yeah, thank you, Rochelle. By the way, I'll keep in contact. I'll try to update the formula sheet if I get like an answer overnight, guys. By the way, it's just so it's if needed, it'll be in the thing tomorrow. But yeah, there's some difficulty with this one. I'm gonna try to get back to this because there's something wrong with what I'm currently doing, and I do need to sort it. But I'll just need a bit more time. Okay, so sorry, Paramvir, if I couldn't properly figure that out. But yeah, I'll get back to you on that. Adesh, so you got that. Yeah, see, the thing is, I got that before, but I don't know, like, did I input it wrong on... I may have input it wrong here. Did I input it wrong here? Or did I do something wrong here? Just looking back on my workings. 1 minus lambda, 1 minus lambda, 1 minus lambda plus lambda. We should get that because times a is a squared. A times a is a squared. We should get that. It is a plus a squared. Sorry, it's just a little bit confusing. Sorry, everyone who can't see my current direct messages. I'm getting secret transmissions. What is the matrix that is just 1 in the bottom right or -1? Did I input it wrong in the first place? Hold on, one moment. I may have done it wrong in the first place. Did I? 1 plus a negative a 1. No, it was right. Might be plus a squared. Yeah, it is. I plus a squared. What? What? Oh my god. Wow. Screw this. Okay. Maybe a real number. I'm just reading through this again. Just give me one moment. Tuck my chair in as well because I'm not very lit. Okay. So it says 1 plus a, yeah. Negative a plus I. That is correct, yeah. So what have I done? Oh! So annoyed. Oh, fuck. Okay. All right. Ignore that, please. Oh, I'm so annoyed at myself. Okay. If I put this in and it automatically solves itself, I'm gonna fucking shit. I bet it does as well. Ah, is that correct? Wait, hold on. No, it is. Oh, shit, I'm so annoyed. Oh, I hate this. I hate this with the burning passion. Oh, I hate it. Okay, right, let's do it again. Okay, so it is just plus a. This still doesn't resolve everything, though. That's the problem. It doesn't do everything we want it to do because it still ends up just with 2 in 1. It's the problem. Yeah, because like you keep doing it here and you end up with like AI, which is fine. So we're just redoing everything, just rubbing out, redo, and then it just ends up like, oh god, no, I need to move. How do I move? That button. I hate this whiteboard, but it still ends up like either way. You end up with AT, which is still fine, but it's like for the specific things here, it doesn't work. Is there like a general solution I'm missing here? Because I feel like there's a general solution I'm missing here. And I've lost another person. Clearly, the time I've taken to do this is upsetting some people. So, I'm going to try to get this solved quickly. Is there some kind of general solution I'm missing, guys? And if so, is there a page I can find it on? Because this is shit. It must be in 3, right? XT, this particular solution. No, that's the other thing. The stationary solution is stable if only eigenvalues are that. Is it like some problem here? Okay, well, I still can't do this. Does anyone know anything further from this? Because this is quite important that we could solve this. No. So, this is where I'm going to stop. I think this is as far as you can really go. I don't see a way to eliminate the I sign from this. It's just, can't quite get it. But yeah, I will try to see how this works out overnight, and I'll post the solution in the morning if I can get it. But yeah, that's that. Okay, moving on. Put this in the past for now. But yeah, also if I record too long. Oh, you got a solution. Would you like to share? Please do. It'll take ages to write up, Ken said later. I mean, you can explain to me here and I can write it. It'll help for the recording. No? No, I need to make sure I'm right first. Okay, guys, we'll consult with Paramvir afterwards and then get you the solution, okay? So sorry to who was asking for it? Sorry to Druv about that. No, wait, it's not Druv. Paramvir. Oh, sorry, Paramvir, but you have a solution, so I guess it's good for you. Anyway, let's continue on. Who has another question? Any other questions and stuff? I'll just wait. If not, then this is going to be very quick. I'll just wait. So I've just got a big book on my lap now. Yeah, I hope everyone's doing all right. I mean, I know like exams can be stressful, but these maths exams seem to be fairly all right so far. Plus, given the last one was mostly exam, the previous exam, then I don't think this will be too much of a concern. So hopefully it will go fine. But yeah. We have another question. 18.4.2c. Did I do this for you? I swear this was the one that you sent me as well. Let me check this. So for context, everyone, we're wrong this entire live stream. Okay. 4.2. 24, that's quite a difference. Did I do this? I think I did this. Or maybe I didn't. Let me just double check this. 25.3.3, which is... Oh, it's a thingy. Okay, cool. 25.3. This is complex numbers, everyone. If P... Oh my lord. What on earth? Okay. Don't even know. So 25.5 is PZ equals 1 minus 2I Z squared plus 3 plus I Z minus 4 plus 3I. Write down P with an overline Z. What is P with an overline Z? To be perfectly honest, guys, I haven't looked through a lot of the book. But yeah, let's have a look here. I assume it's like a solution, because this could be that. I'm going to leave because I'm tired. Okay, bye. Oh, he's already left. I was going to say bye, Jeff, but he's gone. Okay, so, you've asked for this. Write down P dash Z. Is there like a definition of that? Oh, here we go. The conjugate. Right? More people are leaving. Okay. So I'm just looking here. Oh, here we go. Z is a complex number, then P dash. Wait, hold on. Oh, it's conjugacy. The coefficients are real numbers. I'm just looking at the example here. By the way, the guys, this is pages 562 to 5. What is this? Oh, hello. This is pages 562 to 567. Yeah. So 15 point. Yeah, I'm just looking here. This is quite insane. Oh, I see. Right. Fundamental theorem of algebra. Let A to N be complex numbers. There exists complex numbers such that for every complex number. Right. Oh, okay. So it's just factorizing, right? It's like factorizing with complex numbers. Okay. Oh, by the way, who just joined? Mandev. We're doing question 25.3.3, just so you know. Okay. So it says the coefficients are real numbers that the roots occur in conjugate pairs. In other words, if P is a polynomial where all coefficients are real and Z is a complex number, then PZ equals 0. Okay. I'm assuming I'm basically doing I'm doing a quadratic with complex numbers instead there. Yeah? I feel like that's what I'm doing. So if this equals 0, then P dash Z equals 0, and I have to do the complex number here. So, all right. How would I do this then? So factorizing with complex numbers is quite a thing. I guess I could just use quadratic equation, couldn't I? Could I? Maybe I could. Should we try it? Although, can I root one of those? Maybe. I'm gonna give it a try. Yeah, so we'll just try doing -3, -I, plus or minus b b squared minus 4ac, something like that. So 3 minus 1 squared minus 4, 1 minus 2i c, which is just 4. Was it bracketed there? Just looking again. It was not. Okay, so minus 4 plus 3i. So, yeah. I'm just going to go with minus 4, 3i. There we go. And then over 2a squared. So over 2 minus 4, 1, 4i. I think that's okay. I think that's okay. So negative 3 plus or minus, oh god, do the I in. Plus or minus, let me just in here. That's 9, negative 3i, negative 3i. People are leaving. So, and then the 2 i's times together, I squared minus 1. So then it's 8, negative 6i. So 8, negative 6i, and then timesing these together. So you have negative 4, and then you're timesing the i's together, which means negative 6i squared, which means plus 6. So negative 4 plus 6, 2. And then timesing the rest together. So you get 3i plus 8i, so 11i. So 2 plus 11i, I believe. And then times that by 4, which is 8 plus 44i. But minusing that. Minus 8 minus 44i. Does that work? I'm sorry, like I'm leaping in logic here. But yeah. So let me just try this. So that cancels, and then it's negative 50i. Is that right? Yeah, so negative 50i rooted. I could just plug this into Wolfram Alpha, which is what I'm going to get, what I'm going to do if I don't quite get this right. Oh, someone turned on their video. Or not. Nope, they left. Okay, so plus or minus, yeah. So you'd have to do the addition of the I here. So what is that going to be? So you could have like rooting down the I, maybe? Oh, screw this. Okay, I'm going to try to see if Wolfram Alpha can give me something like this. You guys give me really hard questions as well.
Hi.
I did not expect it to be this hard. Oh?
I just had a quick question. You know your first entry for the working out, it's 3 plus I equal to B, but when you put, did you make a mistake when you
Did I
put
make a mistake? Hold on,
in,
please. Is
in
I
the square root?
equal to B?
So from PZ, B is equal to 3 plus I for the quadratic formula, but when you put it in the square root, you put 3
Oh, I see. Right, thanks for the telling me
Okay,
that. Yeah.
I just wanted to point that out.
Yeah, thanks.
No problem.
Oh no, that makes a lot more sense because that was 36. Yeah. So it's negative 36i. Yeah. Okay. Thank you for that.
It's cool.
Yay. Good. Finally, God. Okay, so yeah, I can just take root of negative I, can't I? Yeah. So roots, yeah, like that. So we've got that. We can take root 36 and root negative I, which just turns into 6. And root negative I. Negative I is just 1, right? So root 1. So it's just 6. There we go. All right. Okay, this is making it much easier. Okay, so then plus 6 to that is 3i. 3 negative I over 2 minus 4i. Oh god, it's dividing i's. Oh my god, I fucking hate this. I always hate like dividing complex. I think timesing is harder, but maybe it'll be fine. Yeah. So you have yeah. So you've got 3 minus I over 4. Isn't it like rationalizing denominator? I think that's it. So I'll just do that. So then you have negative 9, negative I, 2 minus 4i, and then going on with that. So rationalizing the denominator of the first one, I would just do. Should this be the 36, not 38? Fuck. Is it? It is, yeah. Fuck it, I'm doing this. I'm just plugging it in. Let's just see. Yeah, does make it harder, doesn't it? Yeah, so let's just do this. Screw this. When in doubt, I just bump on Wolfram Alpha's door and just say like, hey, how you doing? Then it just gives me the answers, you know? I'm just seeing what the opinion is here, because like I'm just stuck. Nope, that's equals. That equals 0. Now, does it work? Okay, it seems to have done it. Does it give roots? Oh my god, that's disgusting. That can't be it, right? I feel like I've missed something here. Write down P-Z. Okay, people are leaving. Okay. I don't really know what's happening here, to be honest. So this has been a great study session.
Louis.
Yeah.
Joe, it says result. That's right. That's what I've got. But if you
that is right. That's
yes. Yeah.
That's just the thing rewritten.
I don't know why, but that's what the answer says.
What?
If you look at Pemberton's text. Look at Pemberton. Look at the actual answer for
yeah,
it.
I'm looking. Wait, where? Oh, it's done down a bit. What? Wait,
Yeah.
no, it's got minus now. Hold on. So it is. Wait, hold on. It's. Pardon me. Just looking at this again. So it's -3i to. What the balls is happening? Wait, it switched signs. Oh, wait, hold on. What just happened? Oh, okay. So it looks like for that, all you have to do is switch the signs of the complex numbers? Yeah, Rashad, just take the conjugate. Is that it? Oh, I'm so annoyed. Okay. So, you heard it here first, folks. I'm really annoyed at myself now. No, I actually don't remove all that. I want to keep some of that. Rochelle, I do not know how it works. It just happens. That's so fucking annoying. Okay, I'm going to be writing that on the formula sheet as well, because like I think more people do need to know that, because that is bullshit. Right. Okay. So you heard it here. When you've got a dash over it, you just do this. They've just taken the piss there. This is bullshit. Anyway, but yeah, okay, so got that. Then what does it say? For this P and C is equal to 2 minus I, verify the conjugate of, oh god. Okay, right. So PC is, yeah, okay, so it wants us to verify that if we insert a value of Z is equal to essentially 2 minus I, and putting that in there instead, then we get the same thing as if we're putting it in here as well, the conjugate of it. So we put the conjugate of C. That's C. That's the conjugate of C. We want to verify that those two are basically the same. We can do that now, which is quite easy. 1 minus 2i, and then putting that in, we get 2 minus I squared. This was much easier than I thought it was. Oh, I'm so annoyed. So annoyed. Fuck the universe, honestly. This is so annoying. Okay, right. 2 minus I, that's just 4 negative 2i minus 1. Yeah, so 3 negative 2i. Okay, and then for this one, okay, so then we'll just write it out again, just to make it a little easier for me, just because I could batch together function things. 4 minus 2i minus 6i, so minus 8i. So no, not 4, 3. 4i squared minus 4. So 3 minus 4 minus 1. And then minus 6i, 8i. I think that's right. Yeah, it is. Okay. Then on with the next one, it's 6 minus 3i plus 2i. So negative I. So negative I. So we've got negative I, 6, and then negative I squared, which is negative I squared, negative 1, plus 1. Plus 1. So 6 plus 1 plus 7. 7 minus I. Okay, and then minus 4 plus 3i. Does this work? No. Messed up somewhere. Ah, fuck. Okay, hold on. What's gone wrong? Wait, what does this even equal? Hold on. Let me just do this. 6, 2, negative 9 plus 3. Okay, well, that's clearly. Which question? No, is this again? Oh, number. 25.3.3. Verify that the conjugate of PC is P dash C. Did I do something wrong? Did I insert the wrong thing? Just trying to look at this again. This has been a terrible day for me. It's just been like, you guys have been giving me questions and I'm just like, yeah, I've been trying to figure them out. So you guys give the hard ones as well. But yeah. For PC here, conjugate of that is, see, I would expect that is just like put that in and then you get it, but oh, it doesn't necessarily mean you have to equal 0. Okay, got it. Okay. All good so far. Just ignore that little thing there. Okay, so we've got 2. We never actually said that it had to equal 0, so maybe not. Okay. Okay. Continuing. Oh god, I feel like I'm going lucid right now. It's just insane. So then we do 1 plus 2i, and then we're doing the 2 plus i squared, 3 minus I, 2 plus I, 4 minus 3i. Yeah, this is how you, yeah, okay, got it. Okay, so, okay, again, we'll have 1 plus 2i, and that is going to be 4 minus 1. Yes, it's going to be the conjugate as well, isn't it? So it's going to be 3 plus I. Yeah, because it's going to be like 4 I squared minus 1, 3. Yeah. Yeah, it does work like that. And then doing this again, we get 4 plus 2i plus 6i, so plus 8i, 4 plus 8i, plus 4i squared minus 4. So, yeah, negative 1. No, not negative 4. Negative 1 plus 8i. Okay, so far it does seem we're just getting the conjugate. And then we're getting 6, and then let's do the other one. So it's negative I squared, so plus I, so 7. And then it's, although it seems to be the opposite here. So because you're getting 6, yeah, so you'll have plus 3i minus 2i, so it's plus I again, yeah. And then minus 4 minus 3i. And then if we solve this again, it's negative 1 plus 7 minus 4, which is 2 again. Okay. And then 8, 9 minus 6. Yeah, it is the same. Oh, my fucking God. Oh, Paramvir, I fucking hate you. This is so hard. Right. Okay. That's that verified. Okay, so doing the alternative, basically doing the conjugate function, putting in the conjugate pair gives you the same result. I think, yeah. So we verified it there. Okay. So that's that question. Any other questions?
You know, 28.2.3, the one that you did before.
Yes.
So I've got a solution to it, and I've sent it to you on WhatsApp if you want to go through it.
Yeah, we can just go through this. Bye. Oh, she's left it, didn't it? Yeah. Okay. You've sent me the solution, have you?
I have, yeah.
Showing up. Oh, Shirom's. Oh, you're together, aren't you?
Oh yeah, sorry, I'm not. I'm not part of it.
You confuse me. Piece of shit. Right.
If that makes sense to you.
Yeah, hold on one moment. Oh god, there's more people with that. Yeah. Also, by the way, do you guys understand the difference equations? Because a lot of people seem to be having problems with that. Is nobody having problems with that?
Which bit?
There's oh wait, hold on. Oh yeah. So, no, it's just that some people went. Hold on, I'll just bring it up. It's this because a lot of people have been asking me about this specific question. Oh, can't show my login info. One moment. Thank you guys for having the patience to stick around, by the way. I know I'm not very efficient, so thanks so far. Oh, good, I've typed in the wrong password. Does that work? Yeah, okay, one moment. Share the screen again. All right, back to it. It is, where is it? Is it, which question is it? I think it's the April last examination, right? Yeah, it was this one. Do that, open. You guys can see that, yeah? Hold on, the Word document. I'm trying to drag it out. Get out here. No, fuck. You go there. Okay, there. God, this is just a fustick luck, honestly. Okay, it's this question, question 15. Did anyone have trouble with this? Because a lot of people did. However, I'll go over your solution later. Or was it Sharon's? I don't know. We'll see. Yeah, did anyone have problems with this question, or is it? Are we okay with that? Okay, I'm assuming nobody has problems with it. Okay, I've lost someone. Okay, right, we're gonna go over the last bit then. Okay. So, all right. Phone fell off. Okay, we're just gonna go through this whole thing again. All right. Okay, let's go back to 28.3, 2.3. Okay, we're ending up with that. Okay, so let's see here. Is this, who's the other person? Adesh also sent me a solution as well. All right. Okay, I've got that. Okay, so you've given, okay, so we know that x dot a, just copying here. Thank you for the help, by the way. Right, so we've got this as what we're starting with. And we know that x equals 0 at 1. And, oh! Oh, fuck. Okay, now I see it. Just drop my thing. Sorry. So, all right, so you're given this as well. Okay, that makes a lot more sense. Okay, redoing what we had. So we had 1a negative a, which we then got into this, I believe, if everyone's everyone's memory serves correctly. And then we got 1 plus or minus ai. Yep. Okay, so those are the eigenvalues. Then we say that, oh, I haven't seen that equation before. Oh, okay, right. So we then say this equation, where is this equation from? look in the book. Bramby, if you know already, just tell people, but I'll look at the book in case. There's some, yeah, so there's this equation. AX is equal to this value X, apparently, in this case. So apparently that's the equation. Just checking through. Got to go into dynamic programming accidentally. Ignore that. Is this somewhere? Where is this? I do not see where this equation is, Bramby. Where is it? I don't see it. Anyway, apparently he's giving me the solution, so I'm just going to go off it for now. So we know that this is that and this is that. Okay. Right. Okay, then. So you're saying then that... okay. Oh my gosh. Okay. All right. So AX is equal to 1 plus AI. X. AY is equal to 1 minus AI. Y. What the fuck is going on? I'm trying to read. Can't read this shit. Is this that? What is happening? Okay, your solution is quite long. I'm just trying to read this through. But yeah. Hey, but that doesn't seem to match, does it? Does it even match at all? Sorry, everyone, for being kind of so slow this evening. But yeah. Negative AI. Okay, well that last part does make sense. So you get like X plus AIX. And then Y minus AIY. But then how did you get the front? It just seems like 1 plus A, which you haven't justified. A is 1 plus A? It's the top. But how is that in both cases true? I mean, I guess like you could just do like that, like XY, and then it's 1 plus A. Is that what you mean? So look at that. Okay, I'm just going to go with this for now. So apparently, it's such that X equals X plus, no, it's the X, and this is true. I'm going off Paramvir's solutions here. Don't even know the word. But yeah, and then this cancels quite easily, so it just goes like, wait, no, that's wrong. Ah! Oh, for God's sake, this is just tiring me out. It's like that. Yeah? Yeah, okay. Which gives you... Okay, so solving the top one, you would get... Okay. Yeah, so you would cancel these out, first of all. So you would get AY is equal to AIX. So you'd cancel those out, and then you get Y is equal to IX. Yep. But that doesn't... I'm just... What the hell is going on? All right. But yeah, okay. All right, I'm just going to go with this. That is correct? Yes, it is. Okay, cool. And then for the next one, you're just going to cancel out... Well, you can't really cancel out much. Is it such that, like... Yeah, okay. So maybe putting X on one side for this one. So X is equal to Y minus AIY minus AY. And then, like, removing that? No, what is that actually going to be? Really trying to look for this. If I like cancel out all the Y's, like I just take that out, then it becomes 1 minus AI minus 1. No, minus A. over x. How is that? What the hell is going on? I am just lost right now. Okay, something's got up. Okay, we are probably gonna. Oh, I've got a chat message. Xi is 2 correct. You also get minus xi2. Right, yeah. Okay. So it's this and this. Don't know how you got that algebraically, but I'm going to go with it for now. Okay. And then from that, you get. Okay. Then you get eigenvectors of. Well, we can technically get those eigenvectors by plugging it back in, but yeah. So you have I1 for. Which one? Oh, I can work it out later. So we have eigenvectors of I -1 and I1, which then we plug back into the general solution, which is then. Oh, okay. So you've said what corresponds to each. Okay, thanks. Okay, I've done something really messed up here. I don't know where this equation came from. So if anyone knows where, then that'll be a help. But yeah. So apparently we plugged that back in. We got C1 e to the power of 1 plus ai, which we've already talked about. And then we've got the eigenvector, which is I -1 for this one, and then repeating. Why did I put t there? Sorry, my hair is falling in front of my face so much, it's just annoying. Okay.
Yes, so it's the same as example 2.
I can't hear you. What?
Exactly the same thing.
Hello? Okay, well, apparently that was a mistake. Glad you rectified it. Okay. So we've got this. Okay, this appears a bit more viable, yeah. Okay, so when t is equal to... Okay, now we use the original things where it said x equals 0. X0 equals 1. And then y0 equals 0. So that's right? Yeah. When t equals 0. Yeah. So putting in the value of t equal to 0, essentially. So we say that we'd get this, where we'd have x equals 1 and y equals 0. So we'd have that. We'd have... So if t is equal to 0, in our case, we have no value there, really, don't do we? So we set our constants, I think. Yeah. So we have... Yeah, so we have I -1. Yeah. And then plus C2 I1, which would give you... Yeah, it would give you the values there. Is that what you did? Yeah. Okay, so we know that C1I plus C2I equals 1, and negative C1 plus C2 equals 0. So C1 is equal to C2. Yep. And so we could basically say, I don't know, C1, 2C1I equals 1. So C1 is equal to 1 over 2I. You've times it by I. Did I do something wrong here? Oh, yeah. Oh, yeah, I see it. So if I'm adding these two, it's just... Or is it? No, I'm not multiplying them. I am adding them, yeah. So 2 they have left. Okay, well, I guess I'm just talking to the rest of you guys. So we've got C1 there. They have told me that, yeah, so 2CI, what have you done here? Okay. What on earth is going on? Okay, what? Sorry, I've nearly got the solution for you. Just give me 1 second. Just reading now. Reading. They've multiplied it for some reason. Okay, I'm just going to go with this. So now we know that the solution is xy is equal to, 1 over 2I e to the power of 1 plus ai t. Dear Lord, this is complicated. Was it -1 or was it -I? I need to double check. It was I -1. Okay, cool. All right. Okay, so we've got that. Okay, now we want to talk about the other stuff, do we? Yeah? Okay, so now we can combine everything. Okay, so looking at the start here, so we have so that times what we've got already, which is e to the t times e to the ait. We've already established that e to the t can go outside, and e to the ait is cos at plus I sine at, but we're also dividing by 2I. What they've written here makes no sense. Cos at. You've done cos at, but you can't eliminate that. Do minus sine t? I know, but I've got the solution here, just sort of on my phone, but I'm just like looking through it and trying to make sense of it. By the way, thank you guys for sticking around. It's nice. By the way. But yeah, just trying to look around here. Solution x equals half. They've not done anything with the I. They've times by the I? Modeling that by that equation by the I. Adesh, I'm looking at your stuff here. Multiply that equation by the I. Do I multiply it? If I multiply it, yes? Okay. Why am I multiplying? I got like 2I. Do I multiply? I'm very confused. Like, why would you do that? The I, in your case, something cancels out with the I. I cancels out with the I. Oh, okay, got it. All right. Yeah, okay, I think I understand now. So you have, let's just move the half out here and then just divide by the I. Yeah? Okay. And then by the cos divided by the I as well. If I divide by I on the cos, does that do anything? Does it just eliminate the sine? Because dividing by the I doesn't do anything except eliminate the sine then. What is it? Just eliminates it outright? So confused. This is going to be a long recording to post to YouTube. Solution e to the sorry. So confused. Divided by that. If you're divided by 2I. I'm sorry, everyone, this is just quite complicated. Negative AI. There's the other one. Yeah, that's the other thing. Okay. But it's like, yeah, so for the other one, it would just be the same thing. Or did I? Wait, I didn't consider that. I see it. Okay, got it. Sorry, didn't look at the eigenvector. God, today is tiring. Okay. And now we times by the eigenvector. Dear Lord, I'm just all over the place today. Okay, right. Okay. Right. Now, what you would do is, oh dear Lord, move down. Okay, so let me just, yeah, okay. So it's then, right, so the I there cancels. And then you have e to the t. But we're back at the start, surely. But then I sine at. Do I expand this? Because if I times by within that, but then the I, can I times everything by the I just cancels it all? Okay, I'm going to go from here. All right. And then for the next part, you would have, well, you would have the same thing, except you've got negative AI, which makes it negative there, which just, okay. So you would have 1 over 2i e to the power of t cos at, negative I sine at, times by, oh dear Lord, what have I done there? Oh dear. Yeah, okay, so times by I1, which then, wait, then the signs cancel out. Hold on, I'm just trying to get this into my head. Okay, so, okay, oh my God. All right, looking at this laterally, okay, if I'm doing the top one here, all right, I end up getting half e to the power of t cos at plus I sine at. Then if I also do the top of this one, I get, oh, for fuck. Okay, I've got it. Right, so doing the top of this one, you get, okay, that took a while, plus et cos at minus I sine t. Oh God, that took so long. Okay, I'm posting the solution to this later because this is just a ball ache. So the signs cancel. You add up those and it becomes e to the power of t. And then it becomes, yeah, just cos at. Oh my God, that took so long. Okay, I think I've got it now. Thank you. Okay, so then negative there. Yeah, so you're just doing, so doing the bottom bits of these two, you have this, put the I there. Oh God, I'm such an idiot. To be honest, I didn't know that equation at the start, and I shouldn't be so self-depreciative. It's been all right so far. Okay, so negative that version, and then adding that version again, but with the sign. Yeah. Okay. So et then cos at, then minus sine. Hold on. Let me just minus I sine at. I think this last part's a little trickier. Yeah. Okay. So just removing. Okay. So we remove bits. So if we cancel out those two bits, cancel out these two bits, you end up with negative cos, negative sine, plus cos, minus sine. So you have two minus signs at the end of it, which don't fully cancel out. Yeah. So you have two. Do you? I might just be an idiot. Oh my God. Okay. But yeah. If I, oh wait, hold on. Just looking through. This time the causes cancel out. Yeah, I see that. So we have those causes removed, but then we're minusing these two from each other. So we have two minus So we have minus I sine AT. Oh, we don't cancel out the ETs. Oh, God. Okay, back. Let's keep those ETs around, yeah? Okay. Oh, dear Lord, I'm just like, I feel like I'm going to hell for like spreading misinformation at this point. Okay, right. And then, okay, so then the I's cancel out because it's not really factorizing, it's just canceling out at this point. So it's minus a half sine AT. Then it's plus the same thing, which then cancels those two out. So let's just remove them. So we're canceling these two out. So we've got that. And then we end up minusing this one again. So we have minus 1 over 1/2 ET sine AT, which gives you negative ET sine AT. And as we said earlier, this was equal to xy. We've done the top and bottom bit now, so we can say, finally, that x is equal to ET cos AT, and y is equal to negative ET sine AT. Okay, I think we're done. Okay, thanks, Atesh and Paramvir, which is gone. So hopefully you guys prepare for the exam tomorrow. Sorry I took so long to pack you those questions. I will put this solution up again. I'll write it out in like a PDF with explanations as well later. And I'll put it on the formula sheet as well because this is just really annoying. Anyway, hopefully that was useful. Sorry that it was a bit tricky in places, but yeah. Hopefully that'll be good. Okay, I'll see you guys later. All right, bye. All right, they just ended the recording then.